Welcome to another episode of AI Frontiers, where the latest and most transformative research in artificial intelligence is brought to light. Today, a remarkable collection of 59 papers published on May 7, 2025, from the field of computer science, learning is explored. This domain sits at the heart of AI innovation, offering a window into ideas and breakthroughs shaping the future of technology. The objective is clear: to unpack key themes, highlight significant findings, and consider future directions in AI learning. Join this journey through transformative concepts and discoveries as the cutting-edge research shared on the ArXiv preprint server is delved into with enthusiasm. Let's begin with a broad overview of computer science learning, often considered the backbone of AI innovation. This field focuses on designing algorithms and models that enable machines to learn from data, make predictions, or take actions without explicit programming for every step. It's akin to teaching machines to adapt and improve, much like humans learn from experience. This technology powers everyday tools, such as recommendation systems on streaming platforms, voice recognition in smart assistants, and navigation intelligence in autonomous vehicles. Its impact spans critical areas like healthcare diagnostics, financial forecasting, and climate modeling, opening doors to data-driven solutions for some of the world's toughest challenges. Turning to the first major research theme, generative modeling and data synthesis stand out. This area focuses on creating new, realistic data samples that mirror real-world patterns. A notable contribution comes from Xiong and colleagues, who guide generative models to design protein sequences with specific properties, potentially revolutionizing drug discovery. Similarly, Wang and team scale up vision models for high-resolution climate downscaling, enabling detailed local weather predictions. The emphasis here is on solving complex problems by synthesizing actionable data outputs that can drive innovation across industries. The second research theme centers on optimization and efficiency in AI systems. As models grow larger and more complex, reducing their computational burden while maintaining performance is critical. Research by Theologitis and others proposes dynamic update schedules for fine-tuning language models in federated learning setups. Meanwhile, Lampinen and team introduce novel algorithms for clustering massive datasets with greater efficiency. The goal is straightforward: to make AI faster and less resource-intensive, ensuring scalability for real-world applications. Next, the theme of robustness and reliability takes the spotlight, a crucial focus as AI systems are deployed in high-stakes domains like healthcare and security. Ensuring these systems perform well under diverse conditions or resist attacks is paramount. Cao and co-authors develop defenses against malicious fine-tuning of language models, while Garcia Borré's group designs manipulation-proof auditing methods for machine learning models. At the core is the concept of adversarial robustness, which aims to protect models from intentional data attacks, building trust in AI for critical use cases. The fourth theme combines temporal and graph-based learning, addressing data that evolves over time or is structured as networks. This includes time series like stock prices or networked data like social connections. Yi and team utilize diffusion models for forecasting time series with shifting uncertainties, while Jin and colleagues innovate with heterogeneous hypergraph models for complex networks. Central to this is the use of graph neural networks, which learn from data represented as connected nodes, capturing intricate relationships in dynamic systems. Shifting focus to key findings, several breakthroughs from these papers stand out for their potential to shape AI's future. Wang and team's Orbit 2 model achieves near-perfect climate downscaling with correlation scores of 0.98 to 0.99 against real-world data. Cao and colleagues secure language models against harmful fine-tuning, maintaining low harm scores. Xiong's protein guide framework enhances protein stability for biotechnology. Lastly, Ye and team's diffusion-based approach outperforms existing methods in time series forecasting, offering better predictions for fields like finance and health. Now, let's examine the methodologies powering these advancements. Deep learning, particularly neural networks, excels at pattern recognition, but requires significant computational resources. Reinforcement learning, based on trial and error, suits dynamic tasks yet trains slowly. Graph neural networks capture relationships in networked data but struggle with scale. Diffusion models generate high-quality data samples, though they are resource-intensive. These approaches form the foundation of current AI research, each with unique strengths and challenges that drive innovation forward. Diving deeper, the first standout paper is Orbit 2 by Wang and colleagues, focusing on scaling vision models for climate downscaling. The goal is to refine global climate data into hyperlocal predictions at a 0.9 kilometer resolution. Their innovation, the residual slim vision transformer, dramatically reduces computational complexity. The impact is profound, achieving correlation scores of 0.98 to 0.99, transforming disaster preparedness and agricultural planning. This work bridges AI efficiency with urgent climate challenges, setting a new standard for real-world impact. The second highlighted paper is Protein Guide by Xiong and team, which aims to generate protein sequences with specific traits like enhanced stability. Their framework innovatively conditions generative models using auxiliary data for targeted outputs. The impact is significant, accelerating drug discovery and biomaterial design. This research showcases the potential of generative AI in solving biological challenges, offering a versatile tool that could inspire further innovation in precision design across scientific domains. The third selected paper, by Serene and colleagues, focuses on reinforcement learning with verification to enhance language model reliability. The goal is to improve accuracy through self-verification at test time. Their approach unifies reasoning and verification, boosting accuracy by over 20%. The impact is clear, ensuring trustworthy outputs for applications in education and customer service. This work sets new standards for robustness in scalable AI systems, addressing a critical need for reliability as AI deployment expands. Looking ahead, the future directions of AI learning reveal exciting opportunities and persistent challenges. Sustainable computing is a priority, aiming to reduce the energy footprint of training massive models. Interdisciplinary integration seeks to combine AI with fields like biology and physics for richer models. Ethics and governance are also critical, focusing on safeguards against bias and misuse. However, hurdles remain, including high computational costs, data bias, and the need for greater model interpretability to ensure equitable and safe AI development. Reflecting on this exploration of computer science learning, several key takeaways emerge. Rapid advancements, as seen in works by Wang, Xiong, and Serene, demonstrate AI's ability to solve real-world problems in climate, biotechnology, and language systems. There's a notable shift toward responsibility, prioritizing efficiency, robustness, and transparency. The diversity of applications underscores AI learning as a foundational field for the future. Thank you for joining this journey through cutting-edge research shared on the ArXiv preprint server. Behind the scenes, this presentation was crafted using a blend of AI tools and human expertise. AI tools assisted in content generation and structuring, with drafting and narrative flow refined by advanced models like GPT-Grok version 3. Text-to-speech synthesis was powered by OpenAI for potential audio narration components, and image generation concepts for visual slides were also developed using OpenAI. All content was meticulously reviewed by a human expert to ensure accuracy and coherence. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the ArXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.